Hey everyone, welcome back to our channel. I'm Yomesh Gupta, and in this video we are going to solve a front-end interview question from Atlassian. This is my third video from their interview process. This question is reported to me by many users, plus it's been reported by many users on the web. It's a commonly asked question where we need to build a feature flag functionality. In this interview video, we are not just going to solve this question. We'll also talk about what are feature flags, what is split testing, what is A/B testing, and we'll briefly touch upon the theory and concept part of it. So without wasting any time, let's get started. So let's say I have this website where I'm currently not logged in, or let's assume that our website doesn't have a authentication mechanism. Now feature flags come into the play, which is also known as A/B testing, when we want to test different variations of the UI or text or some images among our users. We want to see which works well. And so let's say we have this title Ace the front end race, or maybe this complete hero section where we have this graphic image, and I have two variants, variant A where I'll show this, and variant B where I'll show some redesigned version, and I want to see if that's doing better or not. So to enable this, that for 50% of the users will do something and for rest we'll do something else, we picture this feature flags come into play. Now let's say we have a website. So this is our browser or website, whatever you want to call it. So we have a browser. It makes a call to our server. Let's say this is our server, and our server has some sort of logic here which says that 50% of users should see variant A, and remaining should see, or rest of 50% should see variant B. Now server has some logic where it will compute that the request is coming from this browser, and and it's coming for the first time, so I'll assign it, let's say, variant A. So it says that you need to see variant A, or not the request here, it would be the response. In the response it would say that you are assigned variant A, and it will send the HTML for variant A, and we will render now. So this is for the non-authenticated users, keep that in mind. There is no login or anything, but our aim is that if user comes back, let's say user sees variant A, they interact with our website, then they close it. Now when they come back, they should be able to see the same variant again. Like here, after the response, they saw variant A. If they come back at a later point of time with the same browser, then it should be again variant A only, because we want to keep the behavior consistent for that particular user. Now they will also make a request to the server, and server will return some response here. But how the server will know that for this particular user coming from this particular browser, we need to show variant A? Because this information is, if the server kind of considers them as a new user, they might assign variant B, but that will defeat a purpose. Our purpose is that we'll want to show one variant to the user, and we want to make sure that that is shown to the user on subsequent visits. Now here, to achieve this, what happens is that when the user first makes a request and we return a response or HTML for the variant A, the server also returns a header which is called set cookie, and in this, let's say they say home page redesign variant A. So this is the header, set cookie header, that they are returning with their response, and this is set in the user's browser. So next time when user comes to the our website and they make a request, then this cookie is sent with that request. Like with this request, there would be a cookie which will say the variant is A, and server will recognize that this is coming from this browser and we have the variant A as cookie value, so I need to send the variant A HTML. So this is how on the front end side, this split test like in-house split test or feature flags in this case, or you have products like Optimizely. These things work. They set a cookie, and for subsequent request we send that cookie back, and we show recognizes that. Now the question to you is that why are we setting cookie? Why can't we use something like a local storage or something like session storage, index db, something of that sort? Because that is also a valid storage. We get a response from server, we store it, next time user comes we make a request. So why is that, and can we use it? Is it replaceable? Do let me know in the comments. Now coming back to our question, let's see what we have to do in our question. It says that we need to implement a functionality that can be used to show different features to different users. It is commonly known as A/B testing. We talk about it. We have to build a common utility that can be used by entire web app, and we have to assume that the backend is pre-built and a mock function is provided. Basically, a function that will return the status of all the features. Okay, let's see the functional requirement. It says that get feature state should return the value of the provided feature flag. Okay, if there is an error or response is missing, then we should return the provided default value. Okay, return get feature state should support caching with a time to live TTL and minimize calls to backend APIs. This is the secondary part where we are going to optimize the function. So we'll come to that. Now let's see the syntax. It says get feature state. It takes two parameters, feature name, which is a string, and default value, which is a boolean. It returns a promise, which would have a boolean. Okay, like we talked about, two arguments, name and feature name and the default value, and it returns a promise where callback receives the feature flag value, okay, or the provided default value. Let's see a couple of examples. So this is one example which says we want to get the status of show pricing v2 feature flag, and when we make this call, we have this callback in which we get a this boolean, and if it's true then we'll show the new pricing, else old pricing. Same for the show redesign dialog. Okay, good enough. So also the question here talks about authenticated users. It's not talking about the non-authenticated users that we earlier discussed. So in this case there is no point of saving the cookie, because when we load our web app we will make a call to our backend to fetch the data for that particular users, and along with that we can get the feature flags for that users, or we can make a call by passing the ID of that user. But I wanted to make you understand that how these feature flags work in authenticated and not authenticated users. So now let's implement get feature state. Let's see what all we have. We have a couple of sample features. We have this method called fetch all features that's going to mock the backend API. It's going to return the sample features, basically a timeout after 100 milliseconds. Let's implement this. So let me have an example here. Let me just paste an example. So what we want to do is that we want to call show dialog box. We are passing a default value of false, and once we have the value then we'll console log it. Okay, so now in this method get feature state we are returning a promise, so we can say get all features, the call, and once we have the value we'll have the feature flags from this, and once we have that, or let's say we'll handle the error case also. So right now we haven't talked about the error case. Maybe we can add some graceful error handling. In this case what we can do is we can just simply return default value. Maybe we'll add a logger to backend that this feature flag API failed or something like that, or maybe a sentry exception. So now if we got this feature flags, which would be an object, we want to return the value. Our aim is that if we have the feature name inside feature keys, we want to return its value. So what we want to do is object.prototype has on property dot call feature flags. If we have this, then we are going to return feature flags feature name, else we are going to return the default value. Now you must be wondering that why haven't I done something like return feature flags feature name or default value. Now my aim is, let's say this value, the feature flag is disabled and it returns a false, and our default value is true, so the output would be true, which is not right. So that's why in this case policy value is also a valid value. That's why I'm just checking the key. Okay, we have to check the key also that I'm missing here, at feature name. Like if this feature name exists in feature flags object, then we'll return its value, else we'll return the default value. So now if I run this, we'll see it's saying show dialog box enabled, because here the value was true and we are returning it. So if we see our functional requirements, it says that get feature state should return the value of the provided feature flag that we are doing. In case the flag is missing or there is an error, we should return the provided default value. That's also we are doing. It was straightforward. Now comes the part where we need to support caching with time to live, and we have to minimize calls to the backend. Okay, so let's first see the caching part. So I'll create a cache here. So I can say const cache or feature flag cache, whatever you want to name it. This cache will have our feature flags, which would be an empty object, and it would have a timestamp. So basically when the cache was initiated or the value was stored, and we have the max time. Let's say max cache TTL, let's say 10 seconds. And when we have the value, we will store it in the cache. So in this case, after we get the value from the server, we can say cache dot feature flags equal to feature flags, and cache dot timestamp would be date dot now. So this would give us the timestamp in epoch seconds. Or okay, so this is the moment where we are storing the cache. So when we make the secondary call, if we already have the data from the server, we should return it from the cache. So how can we handle this? So here we'll say is cache data present. So we can get this how we can say if object dot keys cache dot feature flags dot length. That means if it's not an empty object, we have some flags, and we also want to know if it's fresh, it is within the max time to live. That the TTL means that during, let's say we make a call right now, we store the data, so for next 10 seconds this data is fresh. Any request coming in within that 10 seconds should be returned from cache, else we'll make a fresh call. So we can say cache data fresh. So for this what we can do is we can check the date dot now minus cache dot timestamp if it is less than. So we are saying the times right now is less than the sorry, time right now minus the time cache timestamp. The delta is less than the maximum freshness time or the cache TTL. That means then we'll get a truthy value, and in this case we'll say if cache data is fresh and is cache data present, if both are true, then we are going to get the value from cache. So what we can do is that we can copy this here, we can call it a value, and here we can say cache dot feature flags. If we have that, then we'll get it from cache and will return promise dot resolve value. Now how can we check this? Let's add a console log here. We can say returning from cache, and we can add a feature name here. So if we test this out, let's say we copy it, we say set timeout, and we'll call it after 300 milliseconds, and we'll call the enable price new pricing. So if I make the call now, see it's saying show dialog box enabled, we are getting the value, for the enable new pricing, we are returning it from the cache. Why is that? Because our cache time to live was 10 seconds, but this call, like first this show dialog box call happened, then this call happened after 300 millisecond of the first call, and by that time our API response was there, because our API response came after 100 milliseconds. So the if we understand this now, we make the first call, we get the data in 100 milliseconds or so, we store it. Next call after 300 millisecond, I'm just mocking it out to show you different scenarios, and we return the value from cache. So this takes care of our cache part, but there is still a particular scenario left here, that let's say I copy this show dialog box and I maybe make a call for a flag that is not present or anything. In this case, let's say show pricing v2, and now if we check our backend API calls, how many calls are we actually making? Call to backend. So now if I run this, see, it's saying call to backend happened twice. Ideally it should happen once, that we first make the call and then anything else should be returned from the cache part, or it should return from the original call. So this is the scenario. Let's say we have implemented this, and it is your common utility is used by so many teams, and on a page there are so many components. Let's say on this page there is this header component which is owned by some other team, this editor component owned by some other team, maybe preview is owned by some other team, and they all are running their experiments, and whenever these components individually are loaded on the screen, they will make their individual calls. So there could be n number of parallel calls happening. And if we have something like that, so let's say if I copy this and I add show dialog or show editor, so this is another call. So this is happening after 300 milliseconds, so this will get the cached response. But these all calls like show dialog box, show pricing v2, show editor, these are calls which are happening simultaneously because it is an async code. So if I make a call here, if we run it, we'll see we are making a call to backend thrice, which we need to optimize in our case. So what we can do here is that we know that get all features is a promise, so we can collect this promise, and all the calls we are going to get in subsequent manner, we are going to queue it. So let me explain what I'm saying in this case. So let's say we create a variable called fetch instance, and we make it null. Okay, and in this case we will make the fetch instance as this value. We'll collect this promise and will return this promise here, so that our functionality remains the same. So right now if I run this, nothing will change, we'll get all the three calls and everything, so our functionality is working fine. And when this promise, so this promise as of now when we return it is in pending state, and when it is resolved, then this whole then block will be executed and the value would be returned. However, let's say if we get the call for this, we'll get the promise, the same promise, and so on. Now for the subsequent calls, what we can do is that we can queue the subsequent feature name request, something like if fetch instance is an instance of promise, that means we have already made the call. In that case, what we are going to do, we are going to return this again, but we are going to queue a callback in this particular case, and if there is an error, then we are going to return the default value. Now inside this, we are again going to get the feature flags, and we can copy this. We don't need to set the cache in this particular case, because uh, what happens is that let's say we initially, let me explain you, let's say we initially get a call for show dialog box. Right now this fetch instance is null, so this if condition won't work. and this block is skipped. We come to this block, the fetch instance will get the promise returned by fetch all features, and we return it. So this is taken care of. Now let's say the at the same time this show pricing call comes into the picture. So after the first call, our fetch instance contains a promise. So we'll come to this part. Fetch instance is an instance of promise. We'll go inside the if block, will queue its callback, that whenever we get the value, whenever this fetch instance is resolved, because right now it's in pending state. When a promise, it's this is important to know, when a promise is in pending state, then you can attach as many callbacks as you want to this, rather than, I mean, in all cases you can attach in rejection state, or you can attach in resolve state, but in specifically in pending state, that when we have a promise in the pending state, so rather than creating new promises, what we are going to do is we're going to queue then callbacks. So when this promise changes from pending to, let's say, resolved, then all these callbacks that we are setting will be executed. So for show pricing preview and show editor, this callback will be executed, and we don't need to set the cache value because our first callback would be setting that value. So now if I run this, let's see if we have implemented it correctly. See, we are just getting one call to backend, and once we have that, we made that call, show dialog box is enabled, show pricing v2 is disabled, and show editor is disabled. These values are not getting from the callback, but these are getting from here. So if I say console log from promise callback, and we can say feature name, and if I execute now, see, we get a call to backend, we have the first value, and for the remaining two, we get it from the promise callback, and then we have show pricing v2 disabled, show editor disabled, and for the last one, which was happening after 300 millisecond, we are getting it from the cache. So this takes care of all our functional requirements. We are supporting caching with time to live, and we are also minimizing calls to backend APIs, because what we are doing is, if we recap, what we are doing is that if we have already a promise, ongoing promise or ongoing fetch call, in that case we are just going to queue the callbacks rather than creating new promises for every call. And once we have returned the response from the first call, we are going to set the value, and we are going to, for the all subsequent calls, we are going to return it from the cache. So this is the end of the video. I hope you were able to learn something new today, and I hope you have enjoyed the solution I have provided. If you feel that I missed out on something or could have done something better, then please do mention in the comments. Do reach out to me on social platforms. There are a couple of links on the screen, topme.io/Yomesh Gupta. If you want to book a session with me to practice for your front end interviews, or want to share your story, or want to understand my path, then you can book a session. If you're unsure where to start the practice, then you can use devtools.tech/practice. This will give you a random question from our database. And as always, do like, share, and subscribe. It means a lot. Your sharing with your friends, your colleagues, and people you may know would really help the channel grow and would motivate me to do well and create more meaningful videos for you folks. So till next time, see you. Take care. Bye bye.